Hi, I am Varun Joshi and welcome to day 39 of our Certified Kubernetes Administrator 2025 course. Today, we'll explore custom resources and custom resource definitions and how they extend the Kubernetes API and let you define your own resource types. We will see how CRDs work with controllers to automate behavior. We will wrap up with a realistic example, a backup policy custom resource, and understand how it differs from the default resource like cron job. So we have a lot of ground to cover. So let's get started. So what are Kubernetes resources? So we have been dealing with Kubernetes resources since the inception of this course. We have played with deployments, pods, replica sets, persistent volume claims, and so on. And all these are Kubernetes resources. Having said that, these are the Kubernetes resources that were available by default in the cluster. So if I go to my terminal and run my favorite command, which is kubectl api resources, then I'll get a list of resources that are available by default at my disposal. And we have been using few of these resources since we started this course. However, there could be a requirement when you would want to create a custom resource. Let's say your team lead comes to you and tells you that I want something in my cluster so that my developers can define their backup policies, and in those backup policies they should be able to define a schedule for the backup. They should be able to define the pvc for which the backup has to be taken. Thirdly, they should also be able to define a retention policy that keep this backup for a month and then maybe delete it. But how do I do that? I do not have a native resource in Kubernetes that will allow me to do this. I can surely have a cron job, but a cron job will just run on a schedule. It does not allow me to supply a PVC which is supposed to be backed up, or it doesn't allow me to specify a retention policy. I want something that could satisfy all these three requirements. First, the schedule. Second, the retention. Third is the name of the PVC. Hence, for this requirement, I, as a DevOps engineer, will have to create a custom resource that would cater to the requirement that my team lead has brought to me. So let's now see what is there in the slide. Kubernetes resources can be categorized into two. There are default resources. These we have been playing with since the inception of this course. And then there are custom resources. Custom resources are the ones that you or a automated system creates for you. Default resources, these are available by default, and the list of those can be found by using kubectl API resources. Second is available in both core and named API group. So if I go back to day 35, here we discussed the Kubernetes API endpoints, and we discussed that these are the only two endpoints which are specified in green that have resources. So any resource that you create will be available in this one, and any of the resources that are available by default can exist in this one or in this one. And we also learned that the slash API is part of the core group. So any resources that are part of slash API are part of the core group, and any resources that are in the slash APIs, they are part of the named group. And we also learned the nomenclature for these. So if I move back to day 39, we learned that default resources are available in both core and named group. Now let's contrast this behavior with custom resources. Custom resources extends Kubernetes API without core code changes. So you can extend the Kubernetes API and define your own custom resources. Second is created by you or external systems, and these external systems can be your automation engines, or it could be various vendors. So if I talk about Prometheus, Velero, or any other tooling that you deploy inside your cluster, you would have seen that all of them or most of them create certain custom resources to extend the Kubernetes API. And that is the beauty of Kubernetes, which is an extensible system. Hence, it allows you to define your own resources based on your custom requirements. So for example, if I want a logging solution in my Kubernetes cluster, then I can deploy FluentD and FluentBit, and most of these tools have certain custom resources that they create. The third point is available only under the named API groups. So the default resources can be found in both the core and named group, but these ones can only be defined in the named group. Fully compatible with kubectl CLI, and this we will see in the demo section. Declarative when paired with a controller. Firstly, what is a controller? So when we talk about deployments, stateful sets, daemon sets, jobs, replica sets, HPA, all of these, they have a controller associated with it, and there are certain resources that do not have controller associated with them. So for example, config map, secret, pod, when deployed as a standalone pod, these do not have a controller. But what is the role of the controller? The role of the controller is to ensure that the desired state matches the current state, and that is the primary role of the controller. If you have a namespace controller, that plays a different role. It manages the life cycle of a namespace. So if we talk about a deployment has a replica count. And how is Kubernetes ensuring that the count that is mentioned declaratively by you in your YAML configuration is adhered to? There is a deployment controller which works with the replica set controller to ensure that your deployment's replica count is maintained. So hence, the role of a controller is to ensure that whatever is defined is adhered to, and same applies for your custom resource. If you have defined in your controller that your custom resource should always be running and should be taking the backups at this time, then the role of your custom controller will be to ensure that the backups are taken as defined in the custom resource manifest. Hence, when you combine a controller with your custom resource, then it becomes declarative, because then it ensures that the desired state matches the current state, and there is a control loop associated with it, and we'll see that in the next slide. Custom resource requires a CRD first. What is a CRD? CRD is a custom resource definition, and to explain this, I want to take you to Visual Studio Code, where what I have done is I have kept a very simple deployment manifest. We are following a certain schema. We define replicas, we have selector, and then we have a template, and we have a spec section under template. Where are we defining all these things? Where are we defining that if someone wants to create a deployment, then we should have these sections and these fields? It must be defined somewhere, and yes, it is defined. If I go to my GitHub repository and I search for API reference, then there is a Kubernetes API reference guide here, and this reference guide will tell you what all fields are available in, let's say, a pod or a deployment. So if I click on deployment, this will tell me what all fields are available at my disposal. So these things are defined somewhere, and since this is defined somewhere, I can use that as a template and then create my deployment manifest. And you can also check this via terminal. If I go to my terminal, I'll clear my screen. If I run kubectl explain deployment, then this will tell me that right under the main section you have 1, 2, 3, 4. So we have defined these 4 sections. And if I go to this also tells the same, that all these fields 1, 2, 3 and 4, all these fields can be there in the deployment manifest. And if I want to see further, if I want to see what is under the metadata section, then what I can do is I can run the same command explain deployment, and then I can add metadata here, and this will tell me what all fields can be there in the metadata section. And you see all these, we have seen a few of them. We have defined name, namespaces in this course, and we have also seen annotations in our deployment lecture. So all these things can be filled. But Varun, why are we discussing this? So if I go back to my diagrams again, if for built-in resources we have a certain format which must be adhered to, then we should have something similar for custom resources as well. And that something is a custom resource definition. A custom resource definition is the place where you define what all fields will be available in your custom resource. What will be the kind of your custom resource? What will be the API version of your custom resource? So for that, a CRD must be defined, and CRD is custom resource definition. So the hierarchy is, you first define a custom resource definition and then you create a custom resource. And optionally, you can also have a controller. And we saw that there are certain built-in resources like config map, secret. These do not require a controller. And there are certain resources that require a controller. So when we talk about custom resources, you deal with 3 primary terms: a custom resource, which we have already discussed. Then there are custom resource definitions, and optionally you can have a custom controller as well. Now, as a rule of thumb, when it comes to built-in Kubernetes resources, think of it like this. If a resource defines a desired state and can drift from it, so for example, if in deployment, if you have defined 4 replicas, but there could be a possibility that you only have 3 replicas, and if you have 3, then that's a drift from what you have defined. So desired state is not matching the current state. So in scenarios like this, Kubernetes usually assigns a controller to reconcile it, and there is a control loop that runs. And if a resource is static like config maps or secrets, which are metadata driven, they are evaluated at the creation time. Hence, they do not need a controller, because if you have a config map, then there would be a deployment stateful set or a workload that would be using that config map. In itself, that config map is not drifting from what it is supposed to do. But when it comes to deployments, they could drift. Hence, deployments have a controller, and anything that defines that is something static, that is not prone to a drift, that can be considered they do not have a corresponding controller. So similarly, if you are creating a custom resource that is just defining the configuration of, let's say, your application, then you might not need a custom controller. But in the demo section, we'll be deploying a backup policy, and backup policy will require a controller because we'll be defining certain things, and those things must be checked. Having said that, we will not be deploying a custom controller in our example, and in the exam as well, you will not be asked to write a controller. These controllers are often written in Go, and you can read the GitHub repository to know more about them. So custom resources, glue that registers custom resource with the Kubernetes API. We just discussed this. So you create a CRD, which is like a template for your resource, and then you create a resource. And if there are any gaps in your understanding, once we move on to the demo, you will understand those things. Second is define the schema for custom resources. So the fields that will be in your custom resources that you define in the CRD. We also discussed this. It's just another Kubernetes object. And this brings me to a very important point. So if you attended the previous lecture in day 38, we discussed about mutating and validating admission controllers. And when we were discussing the built-in admission controllers, then we said that there are certain built-in admission controllers plugins that are used to call the custom admission controller plugins, right? Because there must be a way via which the built-in feature can call the custom feature. Otherwise, if you do not have this bit of integration, then how you will extend the Kubernetes API? To extend the Kubernetes API, there must be some mechanism built into the Kubernetes which will allow me to call that extended part. And when we talked about admission controllers, we have mutating and validating admission webhooks that were calling the custom admission controllers when they were supposed to be triggered. Similarly, if I talk about here, Kubernetes allow you to create CRDs. If I go back to my terminal, hold on, if I go back to my terminal and clear my screen, if I run kubectl API resources, and then I look for custom resource definitions, and you see here, it is an object that is available for me. And using this object, I define the schema of my custom resource. I hope that makes sense. If you want to extend something in Kubernetes, you must have something within Kubernetes built in which will call that extension. And we saw that in admission control. And now we are seeing that in CRDs as well, in custom resource as well. So let's go back here, and this will make much more sense when we move to the demo section of this lecture. Then we have custom controllers. What are controllers? We already understand that. Second is it manages the state, and we'll see that diagrammatically as well. So what do we have on this screen? We have a senior DevOps engineer named Shwetangi, and then we have a junior DevOps engineer named Apurva. In the Kubernetes cluster, we have three things. We have custom resource definition, we have an optional custom controller, and then we have a custom resource. So Shwetangi, as a senior DevOps engineer, would have created a CRD, and she would have also created a custom controller if it was required. Then Apurva, as a junior admin, once the resource definition is created and the custom controller is also created, can create custom resources. And if I talk about built-in resources, these things were already there, not custom. There were resource definitions and there were controllers available, and we were just creating resources. We were creating deployments, roles, and so on. In this example, your developers along with your DevOps teams would be creating a custom controller, and you as a DevOps administrator would be creating a custom resource definition. And then your junior DevOps engineers or your developers could be creating custom resources that will help them define things. In our demo, we will create a backup policy. So for that, a DevOps engineer would be creating a backup policy custom resource definition, and then along with a developer, the DevOps engineer would be writing the code for the custom controller, that how the backups will take place, how will the controller be handling the failures, and so on. There are many things that are involved. And then once these things are done, then there will be your developers who will be just creating custom resource so that they can associate that backup policy with their resource. And this is what we will see. So what is custom controller doing? It is verifying the state of the custom resource. If I talk about controllers, they basically run a control loop, and that control loop observes the desired state, compares that state with the current state, and if it sees a deviation or any drift, then it will take action to reconcile. As simple as that. Now that we are armored with this strong understanding of custom resource and custom resource definitions, let's go to Visual Studio Code and create a CRD. So let's go here. I already have a CRD for you, which we will see in this lecture. CRD. Now, do not get intimidated by this YAML. So if I go to the documentation, you can hold on. Let me just close this one because I already have a browser tab open. So here, let's go to the documentation and I'll search for CRD. And in the exam as well, you will have access to this. So do not worry about this. If I go to custom resource definition and scroll it down, yeah, you see that if you have any confusions, these are available here. But to make sense of this, you have to understand what these fields mean. As long as you understand these fields, you are good with the exam. So let's go there. Now, first is, how is this different than cron job? And we answered that question initially as well. A cron job will just allow you to define a schedule for something, but our backup policy that we are creating will be doing three things for us. First, it will allow us to define a schedule. Let me also zoom this in a little. It will allow me to specify the retention period, and then it will also allow me to specify a target PVC, the PVC that I want to take the backup of. Second question that I want to answer is, will we also develop a controller? So the short answer is no. Controllers are written in Go and you are not expected to know how to write a controller in the exam. How do you define a CRD structure? And we have seen the documentation on how you can define a CRD structure. So let's remove these questions from here and let's concentrate on here. API version is this, kind is this. As I told you before, there must be some way natively which will help us to call the custom resource, and CRD is the one that is bridging that gap. So if I go here, you already know that there is a custom resource definition, and this is the API version for it, and this is the kind for it, and hence we have filled this from there itself. Now comes the metadata section. Here we are saying name is backup policies.ops for operations .cloud with Varjosh. You see, this is plural here. This is backup policies, and we are picking this up from this plural backup policies. So this must be this value. Understand, in exam what they could do is they could just remove this and named it policy, and they will ask you to apply this policy. This will not work because this name, it is expecting the plural form, hence this must be policy. So these are kind of questions that you will see in the exam. Try to apply this, why this is not working, and then unless you understand this structure, what are these things doing, you won't be able to solve that. So the group is ops.cloud with Varjosh. And what is this group? This is API group under which this CRD is exposed. So if I go to terminal again, then this is the group under which stateful sets are exposed. This is the group where token review and all these are exposed. Similarly, the API group which will be exposing this backup policy will be this one. And understand that this is just a group, ops.cloud with Varjosh. Right now I am creating just backup policies here. I could tomorrow go there and create a cost center resource, and that cost center custom resource will be helping me with billing related things. Or I could also create a custom resource called environment binding, which will allow me to specify what are the secrets, config maps, and so on that are associated with my application. And you have to broaden your imagination here because this is organization specific. Maybe you want something from your Kubernetes cluster which is not readily available, hence you decide to create a custom resource for that. And any custom resource that you create will be under a named group like we discussed before. And if I have created a named group like this, then anything associated with operations will be part of this group. For example, right now I have created backup policies, but tomorrow I might create something else that is related to operations. And similarly, you can have a app.cloud with Varjosh group, and that will have custom resources specific to your application. So you have to create that mental picture in mind for the dots to connect. Then you have name, plural backup policies, singular is backup policy. And why do you need that? Because when you run kubectl get pods, you should see all the pods. So similarly, when you run kubectl get backup policies, you should see all the backup policies. What is kind? Similar to what you see here. So if we create a resource using this custom resource definition, then that resource will have a kind backup policy. Short names, we see short names here as well. The short name for endpoints is EP, config maps is CM. Similarly, the custom resource that we are creating has a short name of BP. Scope is namespaced, and that is also we see here. And now you know why this is my favorite command. This helps you with so many things. If I add a -o wide here, it will also give me the verbs associated with each resource. Pretty awesome, right? And then namespace. So you see here namespace true or false. The backup policy that we'll create using this CRD will be namespaced. Versions. This version is V1 for us. Now let's say you are currently developing this CRD, it's not matured yet because you are working on the controller and so on. Then you could have alpha, and that alpha can be matured to beta, and once that beta is done, you can just have V1, which is the version that anyone can use. If you have further iterations, then you can change this to V2 alpha, V2 beta, and then just V2 and so on. Served is true. What does this served mean? It implies this version will be served by the Kubernetes API. Then we have storage. Storage is true, which implies that this object will be stored in etcd. So if you create a backup policy, that will be stored in etcd. Schema is something that you define what all fields will be there in this object. Now this schema is used for validating the object. So if someone is creating, let's say, a backup policy, we know that kind is backup policy. If someone is creating a backup policy, and then if they do not adhere to what you have defined here, then they would get an error because they are not adhering to the schema that you have defined. And we understood from our day 7's architecture lecture that it is first kubectl that performs the schema validation, and then there is also API server that performs the schema validation. If your schema is not in line with what you have defined in your custom resource definition, then creation of corresponding custom resource will fail. So understand that part. Schema is where you are defining what all fields should be available. So here we are saying that schedule should be there, and we are saying the schedule can be in cron format and type is string. So here we are saying at 1 o'clock take a backup. This is just an example for users. Now whenever user will create a custom resource, they will define this field, and we'll see how that works. Then we have retention days. This is type integer, and here I have given the description, number of days to retain backups. Then there is target PVC. Here the users will specify the name of the target PVC. Now let's apply this manifest. I am already in day 39. Yeah, then I will run kubectl apply -f crd.yaml. I'll press enter, and it says your custom resource definition is created and the name is this one like we specified. If I run kubectl get CRD, then you see I have two CRDs created. This one is the one that I just created, and this is the one that I created a while back because I was thinking to demonstrate app configuration, but I thought that most of my Kubernetes administrator folks are from infrastructure background, and if I explain a backup policy, that would make much more sense to them. But if you are from application background, like I discussed here, you can have a group related with your application, and then you can define all your custom resources in that specific group. Okay, so let's go back here. This is this, and then you are seeing we are using the same kubectl command. So if I run kubectl describe CRD, and name of that CRD is backup policies, you see command completion is also working. And if I press enter, I'm getting the results of what I defined in the CRD definition file. And we used kubectl to run this command. So hence, what we said in the initial stages of this lecture, it is fully compatible with your kubectl client. So now let's run our favorite command, kubectl API resources. I'm sorry I took the liberty of saying our favorite command. So if I scroll up, there must be, yeah, here it is, backup policies. Short name is BP like we defined. The group under which it is served is this one, and the version is v1. How cool is that? And then namespaced is true because we wrote namespaced, and then this is the kind, backup policy. Now let's do one thing. Let's create a custom resource that will use this CRD. So let's go here. I'll click here, and then I will split this to right. I'll close this one so that we can have a side-by-side comparison. So if our DevOps engineer or a developer comes in to define a backup policy, so what that developer will do, it will first run kubectl API resources, and he or she will see this backup policies. Okay, this is one, this is the API version, this is the short name, it is namespaced true, and the kind is backup policy. And we have filled those details here. API version is this, kind is backup policy, metadata, the name that I'm giving to this backup policy is MySQL backup, namespace is default. You can even omit this one because by default namespace is the default one. And then under the spec section, like we defined, we have three fields. First is schedule, then you have retention days, then you have a target PVC. Target PVC is the one for which I'll have to take the backup. And if you see here, we have defined these fields. Schedule is like a cron expression. We are saying at 1 a.m. take the backup. Retention is 7 days. So this schedule will run daily at 1 a.m. and the backups will be retained for 7 days. Target PVC is MySQL data PVC. So let's go there and apply this YAML. kubectl apply -f and name is cr.yaml. I'll apply this. It says the policy is created. If I run kubectl get bp, I'm using the short name, I press enter, I see that 10 seconds back it was created. And I can also run a describe on this kubectl describe. What I'll write here, describe bp, or I can write backup policies, and the policy that I want to describe is MySQL, and I press enter and it describes the policy for me. Isn't this wonderful? And now see, this alone will not be doing anything because we do not have a controller yet that will ensure that the things that have been defined in the configuration file must be adhered. So if we had this PVC, the backup won't be triggered because there is no controller that is doing that. But I hope you have a very good understanding, at least from a creation point of view, that how to reverse engineer this, how these things are connected. What is a custom resource definition? Why would you use that to create a custom resource? That wraps up day 39. We learned that while CRDs allow you to define new types of objects, they are passive by default. and it is the controller that brings them to life by implementing a control loop. In the next lecture, we'll build on this foundation and explore Kubernetes operators, which are just custom controllers paired with CRDs, designed to automate complex operational tasks like backups, failovers, upgrades, and much more. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.